Okay, good day, grade 8 students. We are now in quarter 5. Quarter 4, week 5 of our session mathematics. So, what is quarter 5, quarter 4, week 5 all about? The previous video tells about the parallel lines cut by a transversal. So, how do we prove that if the two parallel lines are really parallel? This time, we want to prove that the two lines are really perpendicular. Okay? So, what are the proof that we need if we want to make sure that the two lines are really perpendicular? Okay. So we have here the first one. If two lines are perpendicular to each other, then the pair of adjacent angles they form are congruent. So let us recall the words here, which is perpendicular. So how do we know if the two lines are perpendicular? In your first quarter, when we talk about perpendicular lines, the intersection is 90 degrees. That's the that's the condition. The intersection form 90 degrees angle. Okay. Then, if they are really perpendicular, the adjacent angles. So when we talk about adjacent angles, these are the angles that has same vertex. Same vertex. It has same ray or shared ray rather. Okay. So basta isa do sa ray, yes, parehas sila. Okay. They have one same ray. So if these angles are adjacent, the condition is they must be congruent. Okay. So if angle A and angle B are adjacent and angle A is 35 degrees, angle B must be 35 degrees as well. Okay. Take note class, not all the adjacent angles are congruent. Hindi lahat ng adjacent angles natin congruent sila. Kaya meron siyang specific na condition. The first one, they must be congruent. Okay. So let us consider the figure here at the right side. You have here line 1. This is line 1. And this is line 2. So if line 1 is perpendicular to line 2, okay, and this is perpendicular to line 2, how many angles do we have here? So they form 4 angles. We have here angle 1, 2, 3, and 4. So what are the adjacent angles here? Angle 1 and angle 2 are adjacent angles because they share the same vertex and the same ray. Angle 1 and angle 3 are also adjacent because they share the same vertex and same ray as well. Angle 3 and angle 4, they are both adjacent angles because uh, they have the same vertex and ray. Angle 2 and angle 4, they are adjacent angles because they share the same vertex and ray as well. So these are the adjacent angles. So according to the conditional statement here, they must be congruent. So whatever the measure of angle 1, that would be the measure of angle 2. The same with angle 3. Kasi marami siyang adjacent. Angle 1 adjacent to 2, angle 1 adjacent to 3. So they must have the same measure. If angle 3 is the reference angle or one of the angle here, that is adjacent to 3 and 4. But by let's say, what kind of property is this? By transitive property, since angle 1 congruent to angle 3, angle 4, sige, let me write the proof. Angle 1, if angle 1, let's say class, if angle 1 is adjacent to angle 3 and angle 4, and we want that they are congruent, then according to our conditional statement, then angle 1 is congruent to angle 3 And angle 1 is also congruent to angle 4. But, no, no, no. Angle 1 is congruent to angle 3. Angle 1 is congruent to angle 2. Bago natin sabihin congruent kay angle 4. Angle 1, angle 4. Ayan. No, angle 3 rather, sorry. It's angle 3. Ayan. But we want to prove that angle 1 is also equal to angle 4. So, if angle 3, so we can use angle 3. If angle 3 is adjacent to angle 4 and angle 1, it's angle 1, it's not 9, it's angle 4 and angle 1, then there must be angle 3 congruent to angle 1, then angle 3 to 1, the angle 3 congruent to angle 4 by substitution. Can say by substitution, angle 1 is congruent to angle 4. Okay. Angle 1, pardon, angle 1 to angle 2, and if angle 1 is adjacent to angle 3 and angle 2, and angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3. And if angle 3 is adjacent to angle 4 and 1, then angle 3 is congruent to angle 1, and angle 3 is congruent to angle 4. By substitution, angle 1 is congruent to angle 4, or it could be by transitivity, by transitive property. Should I say by transitive property also? By transitive property, uh, angle 1 is congruent to angle 4. Yeah. Okay. So, how about if we try to construct the perpendicular lines? Okay. Let's have, let's have the GeoGebra geometry. So, what I have here is an online GeoGebra geometry. So, you can download it on your phone, on your gadget. Okay. So, here at this tab, we need to construct a perpendicular line. So if you click perpendicular line, it will tell you an instruction below. Select perpendicular line and point. So we need to make first a perpendicular line. Let's say we make a segment. This line is too long for that. So let's say we want AB. We want line segment AB. And we construct according to instruction, select perpendicular line and a point. So we need to get a point. So let's say this is the point. Let's try here. So we have here point C. And we want a perpendicular line. Okay. So this is the perpendicular line. Okay. So let's have another point here. Another point. Maybe let's try to make a segment. Maybe segment is better. Okay. By the way, what I'm doing right now is I'm trying to make a perpendicular lines, not a perpendicular bisector, because perpendicular bisector, there are two conditions. The first one, it must pass through the midpoint of a line. So unlike a perpendicular line, it can pass through at any parts of the line segment. Okay, so let's make perpendicular line, this one. Mhm. Okay, so it only proves that my line is not aligned. Okay, it's not going straight here. And another. Let's delete this one. Oops. I think it's better if we have point. Pardon. It's better if we have point than perpendicular. Ayan. Okay, so according to GeoGebra geometry, the two lines here are perpendicular line. So, the next thing we're going to do, let's find out the angle measures. So, let's say point two, that's point two. We want an angle measure. So, we want angle, this one. Select 3 points or 2 lines. Uh, okay, that's 90. Here, it's 90. Oh, another 90. Mm-hmm. Again. So we have here 90. Yan. So angle DCB is 90 degrees. This time we are going to select 3 points. Yan. So sa an angle, cancel. Select 3 points or 2 lines. Select 3 points or 2 lines. So we want 3 points. Ayan. So that's 90 as well. Let's have another one. That's also 90 degrees. And let's have the last one. Okay, so that's 90 degrees. So with the support of a proof, a while ago, with the support of a proof, uh, it only implies that the only angle measure that will give you congruent, no, that will give you congruent angle measure is only 90 degrees. Okay? So 90, 90. So angle 1, angle 4. Yeah. So according to the first uh, statement, the pair of adjacent angles they form are congruent. So these are congruent. By construction, they were congruent. They are all form 90 degrees angle. Okay, now let's have the second one. If two lines intersect to form a pair of congruent adjacent angles, then the lines are perpendicular. This is the converse. This is the converse of our first statement. Okay? Wherein our hypothesis becomes the conclusion and the conclusion becomes the hypothesis. So we want to know the converse if it is true. So two lines intersect to form a pair of congruent angles, then the lines are perpendicular. So let's say angle one. So we can prove this by uh, backward, you know. So let's say angle one. Let's say angle one and angle two. Let's say angle one, angle two are adjacent angles. Let's say angle one, angle two, and angle three are adjacent angles. Adjacent angles. So if they were adjacent and congruent, or adjacent angles and congruent, then let's say then angle one congruent to angle two congruent to angle three, and angle one and angle one congruent to angle three. Then let's say Angle 3, angle 4, and angle 1 are adjacent angles and congruent. Then, then angle 3 congruent to angle 4, angle 3 congruent to angle 1, and angle 4 congruent to angle 1. So we can say, by transitivity, by transitivity, by transitive property, we can say that angle 4 is congruent to angle 2. From the two previous statements, we write they are congruent. But how can we prove that they are perpendicular lines? Okay? Since since they are all congruent, since angle 1, what else? And angle 2 are congruent and supplementary. Oops. Angle 1 and angle 2 are congruent and supplementary. And supplementary. Then uh, the two angles measure the two angles measure 90 degrees because 90 degrees is the only angle measured that's congruent and at the same time supplementary. Then the two angles measures 90 degrees. So if they were 90 degrees, they were what? Perpendicular. Not, it's too early to conclude. Angle 1 and angle 3. Let's say angle 1 and angle 3 are also supplementary. Maybe we can conclude in one statement, no? Angle 1, angle 3, 3 and 4, 3 and 4, 2 and 4. Angle 3 and 4, angle 4 and 2 are supplementary. Therefore, therefore, the measure, their measure is 90 degrees. So to sum up, so if their measure is 90 degrees, if all of them measure 90 degrees, then the two lines they were forming is perpendicular lines. Therefore, line 1, I can say line 1 and line 2 are perpendicular lines. By definition of perpendicular lines. By perpendicular. And I think it's enough. Okay, next. Letter C. Maybe I could down, put it down here. Oops. Okay. Maybe we can adjust a little bit. Maybe I could copy. Right lang. Ayan. Okay. So letter C. The last one, letter C. In a given plane through a given point, there is exactly one line perpendicular to a given line. So if we have a plane and we have one point and we have a line that will pass through the plane at exactly given point, there is one perpendicular line, one line perpendicular to a given line. Okay, so how are we going to prove it? So we have a plane here, plane R, and point A and B. So the 2 points A and B belongs to plane R, and they are coplanar. Okay? And B and A form a line. So 2 points form a line. So you have here line BA, and we have another line outside the plane, and it intersects plane R at point A here. So we have here line BC. So if you have line BC here and intersecting, there is exactly one pair of perpendicular line. So this is the proof. Since BC is perpendicular to AB, I think it's AB, it's typo error, AB, about a single point A and forming a right angle, by definition of perpendicular lines, we conclude that there's exactly one line perpendicular to a given line. So let's try to make it in GeoGebra here. Okay. So we will make a polygon, let's say a four-sided polygon. So make it regular and polygon. Okay, class. So supposedly this is the plane ABCD, and we want two coplanar points, and these two coplanar points will form a line. So let's have segment for a moment. So we have here EF. EF. So aside from that, we have a line that will intersect at exactly one point, and that's it. Point E. So this is outside the plane. Do you know if it's outside the plane? See, so if I move the plane, the line GH is not affected because GH is outside the plane. It intersect, it intersect line EF, line segment EF at point H. So let us try if this is a perpendicular. So by definition of perpendicularity, it must form 90 degrees angle. So let's measure. It's 37. Ah, no, my mistake. We must form perpendicular line. Must form perpendicular line. Okay, subperpendicular line for that. Okay. Okay, that's one. That's a perpendicular line here. So the perpendicular line here is intersect at exactly one point, point H. So let's assign a point here. And this time let's measure. Must be 90 degrees. See, it formed 90 degrees there. 90 degrees angle. Let's try another one if it is 90 degrees. Yeah, it's already 90 degrees. So the point here, the perpendicular lines here, is exactly one pair. How about the angle below the plane? So this one is below the plane. So let's have another point. Let's assign another point here. And let's get the angle measure. See, it becomes 90 degrees as well. And 90 degrees as well. And so there's only one pair of perpendicular lines. Now going back here. The best way to prove this is to demonstrate. Yes. In our regular session, we're going to demonstrate this. So that's how we prove two perpendicular lines. If the lines are really perpendicular. But how about if the transversal? What if the transversal is perpendicular to the two parallel lines? Maybe let me show you this. Let's have another instances. Uh-huh. Okay, let's say class we want a parallel line. So to make a parallel line, we need to select a parallel line and a point. So we're going to make a pair of lines and we want to point outside. Then we want a parallel line and we select a point. No, it says select parallel line and a point. A parallel line. If we select parallel line and a point, mali. Wait. Parallel line. Okay, so that's good. So we have two parallel lines AB. Let's give another point here. Say AB and CD. So this is the two parallel lines. And the transversal is perpendicular. Let's combine the one. Perpendicular. So we want a perpendicular. So to make a perpendicular line, how? Perpendicular line. Okay. So we have here a point, select perpendicular line. Okay. And you want your transversal here. So let's say here. And so how many angles do we have here? We have here 8 angles. So what I want you to do is you're going to apply the properties, the angle pairs in parallel lines cut by transversal, and apply also the proof that we have in perpendicular lines. So this will be your investigation. I guess it's an investigation. It depends on how you're going to do it. If you want to do the advanced one, like using GeoGebra geometry, it's up to you. If you want to make it manipulative, in a manipulative way using protractor, any measuring device, you can have it. If you want this one kind of proof, the written proof here, you can have this one. So any of the method you aim to do, it's up to you. As long as you depend it, as long as you use the properties, doesn't matter. Okay, so this will be the end of our session. See you on our regular class. Bye.